Good to go? Okay. Well, good morning, everyone. Thank you for being here on this early session on a Thursday. Appreciate you being here. I want to talk to you about how enabling basically next generation AI workloads with NVIDIA Blackwell, and also talk a bit about our partnership with Azure, which really spans the stack, really top to bottom, and talk to you a bit about that. So that's me, Director of Accelerated Computing Products at NVIDIA. I work in our Accelerated Computing group. And let's keep going. So, you know, obviously you've been at the show, you've been following the news. AI is really everywhere now. It's touching every industry. There really is an industry probably it can't help, you know, bring along and basically amplify capabilities. We call out, you know, some examples here, about a dozen or so examples of different industries where we've already seen AI really starting to make an impact. And of course, we expect that to continue to accelerate over time. As we've kind of moved through this deep learning journey, we have come to kind of observe that there are what we call three scaling laws, right? And you can think of that compute sort of axis label there on the x-axis as time domain as well. So in the early days, you know, kind of in the early, you know, 2010s, let's say 2010s, it was about pre-training, which was to say getting the actual models trained, right? Which was hard at the time, based on the compute we had, based on what people were looking to do, you know, and training times remain still really the big, heavy work. But what we've seen is that there's been the rise of model makers. And of course, Microsoft is one of those with some of their own models and the work they do with OpenAI. NVIDIA is also a model maker with some of our Nemotron models, and I'll talk a bit about that, where you take a pre-trained model and apply your own data to it in something called fine-tuning, right? That certainly is one of the techniques that allows models to be deployed sooner, because while fine-tuning is still a pretty heavy training workload, it's not nearly as heavy as doing a full pre-trained run, right? In addition, there are other techniques such as disaggregated serving, and I'll talk a bit more about that in a few minutes, as well as quantization, which is a really important one of using lower precisions on inference as a way to gain performance, and also in some cases reduce the amount of infrastructure you need because of the memory footprint reduction you get from using reduced precisions like NVFP4. And again, I'll cover that a bit as well. And then most recently, with the kind of the advent and the rise of Agentic AI, suddenly the token load that we have on our infrastructure has increased dramatically, like by an order or two of magnitude, right? So just a massive increase. And so this is driving the need for a lot more compute, not only on the training side, but as well on the inference side. So in some sense, both of these problems are increasingly becoming, well, training already was an at-scale challenge. Increasingly, inference is becoming an at-scale challenge as we sort of begin to deploy more agentic AI applications. So this notion of test time scaling really gets to the part about the reasoning, or the thinking, if you will, where they're the input tokens, a whole lot of reasoning tokens, and then a certain amount of output tokens, depending on, you know, the query you've put into the system. So we've kind of been on this ride where, again, in the early days, it was about perceiving and sort of classifying. We then moved into essentially the generation of content with generative AI. Now we're taking it to that next step with agentic AI, where you have essentially multiple models working together to formulate a more sophisticated answer to more complicated questions, which can include things like the generation of net new content, kind of generative, but in some cases what you're asking it to do is take multiple inputs, look at them, figure out a way to organize them, and give them back to you in the form of, say, you know, a business plan, a marketing plan, a slide deck. It can take any number of forms, right? But the point is that the workloads have become much more sophisticated, which kind of allows us as individuals to kind of amplify what it is we're able to do by using these AI tools. And then kind of the next area where we really see AI, I mean, this is not especially new, but we really see a lot of the sophistication, and particularly the autonomy around agentic AI making its way into physical AI. That is to say, robotic devices, edge devices, things, for instance, like, you know, pallet haulers, for instance, inside of a warehouse, that are able to kind of reason and make sure that they are operating safely, as an example, right? So, you know, AI, you know, and the pace, of course, of innovation, as you're probably well aware, is pretty staggering. I mean, the rate at which we are growing the capabilities of AI, especially now with agentic, has been truly remarkable. So to give just a quick overview, and for those of you who are well versed in this, this will feel like old material, but for those of you who are maybe just getting started with AI, this is just to give you kind of a sense of the distinguishing between essentially knowledge-based AI and reasoning-based AI. You know, knowledge-based AI is a relatively simple sort of Q&A model. You know, you ask it a question like, what is NVIDIA? And it will go and basically do a lookup, probably a web search, and come back and give you a pretty straightforward answer, probably based on sort of the about page of our website or something along those lines. If you look on the right-hand side, we came up with kind of this fun example, trying to get a seating chart right based on a set of constraints, right, around which relatives don't like which relatives, and you want to have a nice, peaceful wedding reception. And so that involves a certain amount of reasoning. This is also sometimes called chain of thought, and you'll sometimes see that in the applications you use, where you'll actually see the steps it's going through. It will show you the steps it's going through, saying, here's how I'm breaking down this problem into smaller components, here's how I'm solving this, 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 and then I'm going to bring it all together to give you a final answer as the ultimate output, right? So again, reasoning really, is a big stair-step function in terms of capabilities, but also in terms of compute requirements. So in order to bring this to the market, we've talked a lot about what we call AI factories. And of course, we're working very closely with Azure. I'll have a slide on that in just a moment about some of the really big work we've been doing lately with them. But the idea of an AI factory is that you have these inputs coming in, foundation models, which I talked about a few minutes ago, which can then be sort of fine-tuned, trained with your specific data so that the model then has domain knowledge of your particular area or discipline. Security, of course, is quite important for obvious reasons. And then, of course, the AI tools to actually build these models, these applications. So this basically comes into the data center, it's fine-tuned, it's prototyped. From there, it can be put into production. And then from there, you have basically your own customized model that's now basically serving your customers and generating value for your organization. And then one of the other key pieces is, of course, this is a loop, right? This is essentially a loop because, after a certain amount of time, if the inputs coming into your model start to change and are essentially sort of diverging somewhat from the training data set you used, you will probably start to see your accuracy fall off a little bit, at which point you may want to consider doing another fine-tuning run based on some of the inputs you've seen over, say, the last 6, 12 months, what have you. Now, there's another technique called retrieval augmented generation, which I'll talk a bit more about in a few minutes, where you can actually be using essentially database lookups, and if the database is kept essentially current, then that's a way to extend the lifespan of that deployed model without having to go back and retrain it for a longer period of time. So this curve you see here is what we call a Pareto curve. And so what we're sort of showing you here is the factory sort of token output versus the interactivity, which is sort of on the x-axis, right? So the goal with a Pareto curve is, of course, to find the optimal point on that curve. Now, here's the interesting thing. There's no one right answer for every organization. I mean, I can sort of mathematically show you that there's some optimal point on this curve between those two values, right? That may or may not be the right answer for your organization because different organizations are going to make different trade-offs. Because as it turns out, sort of you can think of it as factory output or factory utilization versus interactivity, which is to say tokens per second per user, kind of pull at each other, which is to say the more you get of one, the less you're going to get of the other, and vice versa, right? And that's sort of what this curve demonstrates. Now, what we're trying to show you here in this particular curve is you see that darker green Pareto curve. That's from our Hopper architecture, right? And then if you look at what we're able to do with our Blackwell architecture, we believe that we can generate up to 50x more sort of factory output while increasing responsiveness, while maintaining power consumption, which is another big consideration for obvious reasons, right? So that, so you can kind of see the area under, think of it as area under the curve of the 2 points, and you can see that obviously Blackwell will deliver substantially more capabilities there. And I'll get into some of the reasons why in a few minutes. This is especially germane to agentic AI. So in terms of collaborations that we're doing with Azure to build AI factories, Microsoft has been working on what they call their Fairwater data centers, which really can be thought of as AI super factories. They launched one a little earlier this year in Wisconsin, and just about, I believe it was, what was it, it was late last week, I believe, they announced their second one, which is based in Atlanta, right? And you sort of see an overhead shot here of one of the data centers. These are massive, massive systems, and in addition to each one being a super factory in its own right, they're connected via very high bandwidth connectivity so they can actually be joined together to act as a single, just massive data center for doing absolutely cutting edge work. And this becomes critical for building those next generation agentic models. As I talked about pre-training in the beginning of the talk, pre-training remains a very heavy task, and the models aren't getting really any smaller. And the agentic models in particular often have, it's interesting, the total model size, if you take DeepSeek as an example, has over 670 billion parameters, thereabouts. But they're not all active at the same time. It depends on which experts you're spinning it up at any given time to answer a certain question will kind of determine how many of those tokens are actively being used to formulate your answer. But it's still, the fact remains, those reasoning tokens are still introducing massive amounts of compute requirement on today's data centers and tomorrow's AI factories. So as we think about inference, as I talked about, inference is increasingly in the agentic era an at-scale challenge, right? And it's an at-scale challenge for a number of reasons. There's certainly the compute requirement, but we think of these 5 vectors as the things you actually have to think about and solve for. Traditionally with computer performance, the general rule of thumb, faster is better, and you're done. Well, there's a lot more to it than that now as we think about solving for inference. Yes, throughput, which can be thought of as the faster is better part, absolutely still matters, for sure. That said, it has to be balanced with these other things. There's the matter of energy efficiency. Many data centers are now power limited, and there's a big hunt out there now for the next megawatt, the next gigawatt of power to be able to build next generation AI factories. Cost is another consideration, the cost to deploy, the cost to operate. Responsiveness, that gets back to the interactivity piece I talked about a moment ago. And of course, intelligence, the quality of the output matters hugely, because if you're not delivering high quality output to your customers, their user experience is going to be suboptimal, pretty good chance they may not want to come back, right? So you have to be thinking about really, kind of in these 5 dimensions, if you will, as you're solving for particularly agentic AI inference. So we kind of came up with this acronym to help kind of describe what we think are kind of the requirements to meet those challenges, right? It involves scale, the multidimensionality, which I just talked about, architecture and software, and what we call extreme co-design. That is a super important topic, and I'll be touching on that a bit more in a few minutes, all of which, of course, drives ROI. And then with that, of course, there comes what we like to think of as a virtuous cycle, where the technology ecosystem continues to evolve, the software and the algorithms continue to evolve, to bring even more capabilities to the market. And so here's some of the technologies that we have brought to bear to help solve for these things, right? There's our NVLink 72. This is a critically important technology, especially for a model architecture known as mixture of experts, or MOE for short. These are the models that you will see in a lot of today's most popular community reasoning models, things like DeepSeek as an example, GPT-OSS, and certainly others. But those are 2 that immediately come to mind. And so NVLink 72 really helps massively accelerate inter-GPU communication. And I'll have a bit more on that in a little while. Spectrum-X Ethernet is basically Ethernet for the AI era, right? Ethernet's been with us for decades and decades. A lot of traditional data centers and what I'll call traditional Ethernet was not really built to solve for AI. AI has other requirements. I mean, certainly bandwidth, but also latency, hugely important. And so really tuning top-of-rack switches, Ethernet switches, in this case our Spectrum-X switches, to really be smartly optimized for AI is another area where we have kind of brought a better, newer solution to the market to kind of make Ethernet more, I'll call it AI ready. NVFP4, which is an FP4, a floating point 4-bit precision that we've developed here at NVIDIA, is another great tool in the toolbox to help kind of solve for bringing inference, particularly agentic inference, to market in a way that is scalable and cost effective. Dynamo is our inference serving software. This is an open source inference serving piece of software. It's available on the Azure platform, can be run on top of AKS. And of course, ROI, we talked about that on the previous Pareto curve slide. And the fact that open source is just a huge, huge driver of AI innovation, as you guys are probably aware. And so things like our Dynamo software and our TensorRT LLM software, along with these other open source inference frameworks, are all supported and run very well on the NVIDIA platform. So it's this kind of combination of things we believe that helps us solve for those 5 vectors I showed you on the previous slide. So again, I mentioned extreme co-design, and this is where mixture of experts, because of the nature of these, the experts can be thought of as smaller neural networks, right? That all are sort of working as a team to give you that more sophisticated answer. But in order for that to work, they need to talk to each other. And there's usually sort of a controlling neural network, if you will, the reasoning network, that's talking to these other networks, which have specific functions and will be called in as needed depending on the nature of the question. Right? So what that means is that inter-GPU communication becomes hugely important. And our NVLink technology is about 6 or 7 times faster than PCIe, and it's an all-to-all connection, which is to say any one GPU can talk to another GPU through only one hop, a hop through an NVLink switch and then to that GPU. And that's hugely important because it reduces not only, or actually I should say it increases not only bandwidth, but just as importantly, it helps reduce latency. Right? And so we're trying to solve for both things. So NVLink is a super important enabling technology, especially for these MOE type reasoning models. And so kind of another Pareto curve here, and this is from some work done recently in a program called Inference Max that has been run by SemiAnalysis, which is a technology website that sort of follows the AI industry. And what you're seeing here is, again, sort of throughput per megawatt. You see there on your y-axis, and then interactivity. And I talked about a few minutes ago how those things kind of pull at each other. So here are these Pareto curves. This is actual measured data. And what we're showing you here is H200. Running in basically an NVL8 configuration versus GB200 running in an NVL72. So they're both able to take advantage of NVLink, but because NVL72 brings together 72 Blackwell GPUs in a unified NVLink domain, we're able to substantially increase the performance, as you can see here, on the order of 10x. And you see all these other 10x's that follow from that, right? So, this is where NVLink has a huge role to play in making these MOE models as performant as they can be. And then in a similar vein, if we look at cost, you can see here that, looking again, so now actually, if you think about sort of, where's the happy quadrant of this model, it's sort of down and to, well, I'm going to do it for you, down and to the right, to my left, your right. And so what you see here again is that, Blackwell, in addition to being substantially more performant, is also helps lower cost. And that's a little bit counterintuitive because we normally think of, the flagship instances as being, well, they cost more. And while there's truth in that, if the cost increase is much, much less than the performance upside, it's actually less expensive to operate. So it's a little bit counterintuitive, but we've observed that more than once, where the leading instance that's being offered by say Azure in this case can be actually more cost effective than say using a Gen -1 instance. And so Blackwell Ultra is our current generation architecture, and again, it uses NVL72, and you can see here just sort of a quick diagram on, on the die shot where we're showing what's called the HBI, which basically it's two reticle limited dies brought together and connected over what we call an HBI, which is like an 11 terabyte per second interconnect between the GPU cores, right? And so, so it's just a massive, highly capable compute engine. And then, of course, we have our rack design, which we call Oberon, and this is where we bring together 72 of those GPUs, along with 36 of our Grace CPUs, along with our NVLink switches, and they're all in different trays there. And you can actually see one of these on the show floor at our booth if you want to get a closer look, and you can even get a selfie taken with it if you want to. And then, of course, software. Software plays an absolutely critical role, right? And so software and ecosystem support just have a massive role to play. And it's not just, sort of the GPU code that we're looking at. We're also looking at, kernels which can be thought of as these very small, very highly optimized programs to run specific math operations, are not only relating to compute, they're also related to communication, right? So this is once again coming back to this idea of communication kernels, because the more we go to at scale, and if you want to think about this in terms of, say, Amdahl's law, the more communication overhead can actually become your gating factor if you haven't really implemented a network architecture that's AI ready, right? So again, multiple factors coming into play here, but again, the software piece, and I'll talk more about that in kind of the next section of my talk, is absolutely critical to making AI basically really reach its full potential. So the ND GB300 V6 VMs on Azure feature GB300. I believe these were announced by Satya. They just did a walkthrough at their Atlanta Fairwater data center. And so there's actually some video of that you can probably find online. And again, just a massive system. And then they recently did an announcement where they're able to hit over 1 million tokens per second on Llama 270B. This is in a single NVL72 rack, so just sort of a kind of a show of what it's capable of in terms of just massive throughput within a single rack, right? And again, like I said, you can see one of these live and in person at our booth. So in terms of some other performance data, to give you a bit more context, this is from the most recent round of MLPerf Inference, which is an industry standard benchmark that measures AI performance on both inference and training. These numbers are from the inference side of things. Blackwell Ultra and Blackwell, just sort of Blackwell, which is GB200, Blackwell Ultra is GB300, basically set multiple performance records, most notably on the most challenging workloads in this benchmark. And those are DeepSeek R1 and then Llama 3.1405B, which is just a massive model, right? So, so what you can see here in terms of our advantage over other competitors you see here, and we were a little bit playful in some places where frankly no one's ever submitted. So at that point, we're infinitely faster. But the point being, you see the multiple X factors here in terms of the amount of performance that we're able to demonstrate. And what's important about these data in particular is that this is an industry standard benchmark that's peer reviewed. In other words, all submitters basically submit their results, at which point there's about a 4 to 6 week review period where all the submitters can review every other submitter's submission and ask questions and challenge even, in some cases, if they think that there's something in there that looks maybe a little not quite right. So this is not sort of the typical, what I'll call benchmarking stunts. This is actually done around a lot of rigor and good benchmarking science, and also because it's an industry consortium with multiple players, some of whom are competitors. There really is that vetting, that holding feet to fire review process. It means these data are solid and directly comparable to one another. If you go to the ML Commons website, you can see all of these data. So in terms of other instances available on Azure, there's 3 broad categories that Azure likes to talk about with their GPU instances. They're NV, NC, and ND. NV is basically for graphics and visual compute, which is to say sort of a combination of both, right? And I'll have a bit more to say about that in just a moment with one of their latest instances they're just spinning up now. Then NC is for inference and HPC compute. And then finally ND is that's the really big iron for doing the heavy duty training and increasingly the heavy duty inference. Again, coming back to the comment I made earlier about agentic inference being really more of an at-scale problem now. And so in terms of getting a little bit more detail on the specific platforms that they're offering, we just wanted to kind of call these out, right? And you see them here. And so, obviously Blackwell, which we've talked about, they also have very capable Hopper instances, which you see here. They also have an instance called Hopper V5VM. And what this is either 1 or 2 H100s that are basically connected to each other via our NVLink fabric technology. So while the device is a PCIe device, those 2 GPUs inside sort of that NVLink domain communicate over NVLink, which, as I talked about, is much, much faster than PCIe. And then finally, they also offer an H100 instance with confidential computing, which is essentially a trusted execution environment that encrypts data between the GPU and its memory, keeping your data and your applications secure. So the latest addition in the Blackwell family is going to be what we call the RTX Pro 6000 Blackwell Server Edition. Yes, I know that's a mouthful. It was not my first choice for a product name, but it's what we wound up with. But it's a fantastic product because this is really our most versatile product, because it has not only capabilities around AI, which include, of course, our tensor cores and other sort of architectural features we have to accelerate AI, but it also has RTX cores to be able to accelerate visual workloads. And so in particular, this is ideally suited for running environments like Omniverse, which is an NVIDIA collaborative environment for doing digital twinning, as well as collaborative work for multiple people who want to be working on the same project that can be essentially using what's called physics-informed neural networks. So basically environments that obey the laws of physics that you can develop, and we have some examples here of the types of things that can be developed in Omniverse, and not only sort of tested and modeled, but also visualized, right? So this is now in public preview, here on the Azure platform, and we're very excited to see what you guys are going to build with that. And that sort of then gets extended into on-prem with some of our OEM partners, including Dell, HPE, and Lenovo, with what's called Azure Local, right? Where these systems are then basically running on-prem, and you sort of have that option to do some of your work on-prem, and then, as I will say, move some of that work to the cloud or burst to the cloud as needed to be able to do your work there. So it's just another way to deploy RTX Pro 6000, depending on sort of the needs of an individual customer, and if they want to have some of their compute local in their own data centers, this becomes a great option. So I've talked a fair amount about hardware. So now I want to shift gears and talk about software, because as I kind of talked about at the top, AI is truly a full stack challenge. It challenges every layer of the stack, from the application down to the hardware and everything in between. So for us, it starts with our CUDA-X libraries, right? We now have hundreds of these libraries. This is just a small sampling of some of them and what they do. You can kind of read the functions and see what they are. But these are being constantly updated and optimized. We release production containers for our software on about a monthly cadence, and then that software becomes available in the Azure platform. Many of our models are now available in the AI Foundry marketplace, so we are just constantly optimizing, improving our software, which brings more ROI when you're running on that same platform and you're getting more upside, more performance upside and capabilities upside from the software that you're running on that same platform. That's basically, think of it as almost free ROI, right? You know, you've kind of invested in the platform and now you're getting more performance, more goodness out of it. That ultimately translates into more ROI for the applications you've deployed. So as I talk about inference, you know, inference in some sense isn't really one workload, it's actually two, because there's two big steps to inference, right? The first one is what we call prefill or context, it gets called both. And the second step is what's called generation or decode, right? They have different performance characteristics, and we sort of show that here in the graph you see on the right-hand side of the slide, where basically the context or the prefill is very compute limited. It tends to be compute bound. It doesn't necessarily need as much memory bandwidth, right? Whereas when you go to do the generation pretty much hits everything, but especially it hits memory bandwidth quite hard. And so what we've studied, and others have studied this in the community, to be clear, we didn't invent this, but the community, it's an idea that was developed in the community that we've taken and implemented in our Dynamo software, where you're basically going to separate the work. You're going to take pre-code and run it in one place, and you're going to do the prefill, and then the decode you will run elsewhere. You'll run on another GPU. And by separating the work, we call this disaggregated serving. And it turns out this can bring some really interesting performance upsides, which becomes especially important, again, given the kind of the computational requirements of agentic AI. So this just sort of illustrates for you kind of the two steps, right? And you sort of see that, you know, this idea of conceptually that we're able to, you know, have this operate on two different GPUs. But one of the interesting things is with our Dynamo software, you see this bit here about the KV cache transfer, right? So the KV cache is a key value cache. These are values that are getting calculated generally during the context or prefill phase. They are pretty computationally expensive to generate. And so like, you know, any data you've already computed, if you can pull the already computed value from a cache rather than having to recompute it, that's a performance upside, right? You're saving yourself work, you know. The fastest work you do is the work you don't have to do again, right? And so, so this is a really important feature that's in Dynamo, and again, I've got some more on this, but if you see here, you know, this idea that we're getting multiple X factors of throughput by using this technique, again, which we make available in Dynamo. And again, Dynamo is available today on the Azure platform. It can be run with the Azure Kubernetes Service, or AKS. And in this case, we're showing it running on the GB200 instance. And you see here, there's a link here at the bottom of the slide if you want to learn more on the Azure website. But a couple of other features to call out with Dynamo. I talked about disaggregated serving and the KV cache management. In addition, there is also, it's an open source piece of software. So in other words, if you want to take Dynamo and basically refactor some of the code for your particular application, that's something you can absolutely do. More importantly, if you look at the inference frameworks that are supported down there at the bottom, you'll notice that we support all the major open source frameworks, which include SGL, or SGLang as it's known. SGL is just their logo, VLLM, and of course PyTorch. In addition, we of course also support TensorRT LLM, which is our own inference framework, but all run very performantly and can be used with Dynamo in conjunction with AKS. Another sort of set of software assets that we make available on the Azure platform is what's known as NVIDIA AI Enterprise, as well as Omniverse. Now, Omniverse I touched on a few minutes ago, so I'm not going to spend too much time there. But AI Enterprise brings together a whole multitude of tools in addition to bringing you NVIDIA basically enterprise-grade support. So particularly if your organization is relatively new to AI, you're just getting started and you think you're going to need some help building your applications, NVIDIA Enterprise becomes a great resource, not only for the software you're accessing, which is containerized, optimized, and security scanned. In addition, you have access to NVIDIA support to help you build some of those early applications. So here are some of the building blocks that you can find inside of NVIDIA AI Enterprise. They include blueprints, NeMo, which is a collection of models, and I'll talk more about that in a few minutes, and then NIM. So NIM is NVIDIA Inference Microservices. And what you see here is we have different models that have been essentially containerized, optimized, and configured so that they can basically just be spun up and run on the Azure platform, right? The NeMo models, of course, we've been working on for some time. It's a lesser known fact, but NVIDIA is in fact also a model maker, right? You know, Microsoft's building its own models. Of course, there's kind of the well-known model makers, you know, xAI, Meta, OpenAI, of course. But NVIDIA also, our Nemotron family of models is something that we're actually quite proud of, and those models are available in the AI Foundry Model Garden, right? And then Blueprints kind of brings it all together for application-specific workflows, where we combine multiple NIMs together, and again, you get sort of access to essentially a almost ready to deploy application, which you can, will speed basically your time to market, right? So speaking of 𝗦𝗲𝘀𝘀𝗀𝗀𝗀 models, it's a family of open models with fairly permissive licensing terms and conditions. Uses massive amounts of data to train these models. There's multiple models. We have kind of the 3 different size models you see here. We've already seen over 1,000 derivatives in terms of people taking these models and then tweaking them for their own particular use cases. And then, of course, there are libraries which help to then accelerate these models. So this is something that's widely available. These, again, are open community models. I would encourage you to try them out, take a look at them. You can learn more about them as well on both ai.nvidia.com and build.nvidia.com to sort of check them out. And so here are the models that are available today, again, kind of in 4 broad categories, reasoning and agentic, which we've talked about quite a bit so far. Vision language, also quite important, as well as information retrieval, or RAG for short, retrieval augmented generation as it's known. And then content safety, things like guardrailing, making sure that answers are remaining appropriate and on topic, right? So, and these models, again, are available in the model catalog, and we have more on the way. So, it's a good space to keep watching. But, at this time, some of the models you see here, I would definitely encourage you to check those out and see if they're applicable to maybe your next project. So a little bit more about NIM. So again, NIM, basically, it's enterprise supported. It can interface, of course, with Dynamo. It takes full advantage of TensorRT and TensorRT LLM to get optimal performance. And again, it's containerized and already pre-configured, so it's very quick to get these models up and running on the Azure platform. Using standard APIs, of course. It has management observability. And of course, is also interfaces very readily with Kubernetes, which helps with things like scaling, orchestration, and things like that. So here's just a bit more on NIM. Here's some example NIMs you see here across the top. And this is just a sampling of them, right? We're working with multiple partners. We have over 170 of these NIMs now. And again, they're available and free to use. And of course, they can be run on the Azure platform. And you see some of the technologies with which they can interface on the Azure platform. So again, a great tool to help you get to market faster. And generally getting to market faster means time, accelerated time to value, which, for those of you who are doing POCs in particular, proof of concept type applications to show the value of AI, being able to build them faster and come back to your respective management chains and go, we've built something, we used NIM, it got us up and running a lot faster, and we think we're ready to scale this. Gives you maybe a much better chance of having that POC turn into a deployed application at scale. And as I mentioned, Blueprints kind of brings together multiple NIMs to create essentially custom workflows, and we have a few of those enumerated here, so you can just kind of read and see what they are on the slide. And again, these are, and we continue to build these, by the way, because it's sort of taking the puzzle pieces and putting them together in different configurations to solve for different use cases. So this is something I'd also encourage you to check out, because it's another way, again, to get your apps built and deployed more quickly. So I talked about physical AI at the top, robotics and such. This is going to be a massive, massive industry, multiple trillions of dollars. And so we continue to build out tools to help accelerate this, the primary one being Omniverse, which I believe is my next slide. But you see a few just sort of factoid figures on the right-hand side about just kind of the size of the market. If you want to think of that as your total addressable market, it is a massive market, and one that we believe a lot of organizations are going to be looking to bring AI into to help kind of accelerate and basically improve the capabilities of these various industries and various pieces of those industries, right? But again, physical AI doesn't really start, you sort of can look in the physical world, but ultimately a lot of it begins in simulation, right? And this is kind of the magic of Omniverse and using things like the RTX Pro 6000, because it allows you to essentially build, say, your warehouse, your factory assembly line, your building, your whatever, and then basically play with it. In other words, play with it in a simulated environment that obeys the laws of physics, and try out different pathing, different types of optimizations around what you're looking to build. It could be as simple as something like the pathing in a warehouse to make sure that, say, forklifts and devices that are hauling around pallets remain on safe pathways to make sure that they and people are not colliding with each other, because that could ruin your whole day. As well as things like optimizing assembly lines. Like we've seen companies like BMW actually use Omniverse on the Azure platform to actually optimize some of their assembly lines. And again, the beauty of that is that they were able to first build it and then play with it, modify it, tweak it to come up with the optimal design before they ever basically assembled a physical piece of that assembly line, which can lead to just essentially massive savings. Because if you go way down a path building a large piece of infrastructure only to find out that your design is suboptimal, if you're going to go and try and fix it after the fact, that can be very expensive, both in terms of downtime of the asset as well as just the physical movement of the things that you have to then kind of reconfigure. But if you can do all that in a virtualized environment before the first brick is ever put into the building, that has really great opportunities to not only get you your most optimal design, but really save you a lot of headache down the road. And again, Omniverse is what makes that possible. I've talked a bit about Omniverse. I won't dwell too much on this one. But again, this is a really cool environment, readily available on the Azure platform. The RTX Pro 6000 is an ideal platform on which to run Omniverse because of its combined AI and visual compute capabilities. And it's something, if you're thinking about building something really big and really physical and you want to do some simulation of it, I would definitely encourage you to have a look at Omniverse on the Azure platform as a place to kind of start that project. So we also have what are called our Cosmos foundation models. I'll just click through these here. And here you see that kind of there's 3 general models here that we're working on. These are what we call world foundation models. These are to help essentially assist in building these environments in the Omniverse environment. And so you see them here. A couple of them are available on Azure today. Cosmos Predict and Transfer are the ones that will be coming soon. So stay tuned for those. But Predict is available as we speak. And so, and again, through the AI Foundry model catalog, right? So these are also models we're checking out if you're thinking about working with the Omniverse platform. And again, this is us trying to bring together the right set of tools so that as you go into that environment, you're able to readily stand up the thing that you're looking to do the digital twinning of, to be able to kind of work with it and optimize it and get it built sooner. So we do a lot of work with Microsoft and of course Azure, who is which is their cloud platform. And it's important to understand that, while yes, they have a wide array of GPU instances that we've been very happy to work with them on and collaborate with them on to bring to market. That said, the GPUs are just the beginning, right? And I think this is a really important topic. We have what we consider a full stack partnership with Azure, right? It runs from, yes, that infrastructure all the way to the application layer, all the way out to customers, and again, everything in between. A lot of the Microsoft and Azure services that are running today on the platform are in fact accelerated by NVIDIA. We show you some of the use cases there in that second box from the top. But the point being is that we are working day in and day out with Azure engineers mostly on a lot of software projects, actually. We actually have more software engineers at NVIDIA than we do hardware engineers, which surprises people because we're sometimes, what I'll call the old perception of NVIDIA is, oh, well, they just make the GPUs. Well, we make a lot more than that. We make models. We have a ton of software engineers. And again, we're working up and down the stack with Azure to make their platform the best it can be. So what I'd like to do now is just show you a short video that's sort of a great customer example that shows real-time weather intelligence done at massive scale. This is using what's called our Earth 2 platform on Hopper GPUs running on the Azure platform. So let me roll that for you.
Weather is impacting everyone, not just every business or every organization or country. It impacts every human being.
This is the game of early warning. You need to be able to provide that insight in 15-minute, 3-minute increments from the moment that you collect it to tell someone, hey, this is going to impact you and here's what it means to your operation and this is what you need to do.
The constellation that we've built in space is just the first step in creating a truly global AI data infrastructure that supports everything weather and climate for everyone. That's what we're trying to do as a business. That's our mission.
People underestimate the size and scale of weather data, right? Remember, we're talking about Earth here. It's massive.
The solutions that Microsoft and NVIDIA brought are incredible, global, and scalable. Now, with tomorrow running on Azure infrastructure using NVIDIA, we can modernize a meteorology agency capability overnight.
And thanks in large part to the NVIDIA team in Earth 2 that's helped us to be able to rapidly take an observation of Earth and post-process it at speeds that we've never seen before and deliver it as an insight built on top of the Azure stack. It allows us to be able to make data more valuable worldwide across governments and enterprises. So many different entities have different types of ways to observe the atmosphere.
Years ago, we could have only imagined having all these data sets being leveraged on modern models in minimum latency, most efficient way on the cloud. When you have all of it together, that's how you can really bring the vision to life.
Okay. So, I mean, that kind of illustrates, what, at-scale deployments can do, right? In terms of, doing atmospheric modeling, as they talked about in the video, is a huge challenge because the Earth is a pretty big place, as it turns out. So another great example here is Basecamp Research, who is looking to basically map global biodiversity. And so what they're working on is developing data sets. These data sets can be used for things like protein discovery and protein research, a lot of which plays a critical role in things like drug discovery, as an example. And so, you see a quote there in terms of, how they're using it. But unlocking new proteins is a huge, it's been actually something that's been worked on for quite some time, but that ability to arrive at them faster is hugely important. And so Basecamp is doing some really important work in this area. Another example is Pangea Data, who is basically working to improve overall quality of patient healthcare. And again, a lot of people basically go with conditions that are either undertreated or untreated. And by using basically data discovery, Pangea is figuring out ways to help understand, from a, you can almost think of it as a kind of triage that says, hey, there's enough signals, in sort of this patient records data that, we really need to get them in to be seen because there could be something seriously wrong that they need to get addressed. Or it's something that they haven't really properly treated and they really, frankly, need additional care to ensure that they're going to have good health going forward. So we're seeing a lot of research in the area of healthcare life sciences. It was one of the early areas actually where AI really started getting used, even before generative AI. In other words, for things like image analysis, things like stroke detection is a great example. Ohio State University did some great early work there some years ago. So, AI and healthcare have been kind of working together for quite some time, but this is another great example, and as was the previous example, of how it's being used now, and we expect that to, of course, continue to enhance its capabilities over time. So, in terms of learning a bit more, please do stop by our booth. This is my last slide. And you can, like I mentioned, you can see a GB300 NVL72 live and in person. You can even enter to win a DGX Spark. I don't know if you guys have seen that platform. It's basically a supercomputer that fits in the palm of your hand. It is a very slick little device. We have them on display in the booth, and we're running a contest there. If you come and I think watch just a single demo, you're entered to win a Spark. It's a very cool development device to get you started with building your AI applications, and then can basically take that early work and then push it onto the Azure cloud to continue working on it at scale. We also have RTX Pro on display there as well. But just come by with your questions. We'd love to hear from you on the projects you're working on and how we can help you, bring those projects to fruition. So with that, I've got about 1 minute and 40 seconds left. I guess I don't know if we're set up for Q&A. I can take a few questions, or I'll be available for a few minutes after the talk if you'd like to come and chat. So with that, I'll say thank you for attending. Appreciate you early risers being with me this morning, and enjoy the rest of the conference. Thank you.